Hello. Within this video, we will be looking at setting up wall attributes and associated framing tools. Please note, dependent on customization, there may be differences to your own environment. To open the wall library, first right-click in 2D or 3D and select Insert Wall. Alternatively, from the Modeling tab, select Insert Wall, as shown in the top left here. Once selected, the wall library will display where you can select from a variety of different wall types such as exterior and interior framing as well as architectural type walls. Presets and customized wall types can also be added, which we will cover in a different tutorial. This tutorial we will choose an exterior CTU framing wall. Within the layers column we can see that the various materials and their respective thicknesses used within the wall structure. There is also the wall height per layer as defined per the Z levels shown here. Each layer has different options dependent on the layer type selected and alters the variables accordingly. These can be manually adjusted. Please note, the pink frame layer controls all of the other layers. Layers can be altered by clicking in the material column and selecting the appropriate option. To access the parameters for the actual structure of the wall, click on the framing layer within the material field, right-click and choose Framing Tools, where the Framing Tools window will then be displayed once selected. Within here, default values will automatically be added from the wall library and the wall framing parameters, however, all can be overwritten based on your requirements. The first tab is the General Framing tab. Here are various basic parameters from the wall framing such as corner details and stud spacing. Framing details determine if the wall is load bearing or not and adjust the point as per the system parameters. Panel label is the graphics used when the user generates the panel breaks. This will automatically pick up the level of the building the user is placing the wall into. End panel tolerance enables the user to shorten panels to create a gap at panel breaks. The Under Truss option, when selected, will add additional studs when generating the framing and any truss envelopes. Moving on to the Frame Tracks and Studs tab, here you can define the profiles used in various parts of the frame. Single or double top tracks and their respective profiles can be defined here. For blockings, there are a combination of options. Flat horizontal bracing that runs on the outside of the panel can be toggled on and off, with the faces to be added determined by the type field. The integral layer bracing has three main options: a continuous brace along the panel, staggered blockings in each bay, or no blocks at all. For each type you can define the height from the drop down box, or simply type in the height or height of the bracing required. Moving on to the Frame Openings tab. Here you can set up the rules for the opening types and the side stud profiles and quantities to be used. One of three definable header types will be used dependent on the opening's width with relation to these two definable values. The type of header style can also be defined by clicking the select button, and much like the corner types are selected using the diamonds as shown here. The Advanced button allows you to add in further options for the opening details such as control over sill types, crupple rules, and further accessories such as lintel plates. Moving on to the Frame Bracing tab. This enables you to define diagonal bracing integral to the panel. Each type can be toggled on or off with the left and right putting in diagonal bracing into the panel ends and or putting bracing into each bay. You can define the type of bracing added in each instance as well as setting a minimum bracing gap. For each, you can define if it's just a single brace or a K-brace. In the Frame Service Hole tab, you can customize service holes further. Default takes the value previously found in the system parameters, and you can then overwrite this by typing in the required heights. You can also determine hole type use by the drop-down menu. This, however, will depend on the available tools on the roll former being used. There are also two options to toggle adding service holes to the top track and blocking in the center of each stud bay. and also options to add connection and orientation holes. Next is the Frame Anchor tab, which allows the user to add in panel anchors from a variety of different manufacturers to both the top and bottom plates. You are able to set a minimum distance from the flange of the stud using the offset distance, as well as also being able to define a maximum distance between the anchors. Finally, there is the Insulation tab, where you can add integral insulation to the frame. Setting the type and if it continues to the inside of the profile, we can then click OK to set our framing attributes. However, if we are looking to have sheathing broken down into each individual sheets, we need to ensure each sheathing layer has its own framing tool. Again, right-click in the material column, however this time for a sheathing layer, and select Framing Tools. You can then select a different sheathing method dependent on the behavior required. For example, the sheet direction can be altered, and you can define if the sheets match the stud layout. This is required for each individual sheathing layer. With the attributes then adjusted, we can now click OK, and we are then ready to begin adding our walls, which we'll cover in our next video. Thanks for watching.